Alright, so this was the fifth most missed question. I was very impressed that as many of you got this right as you did. This is a tough one, I'll be honest. It's right on the verge between what College Board could include on this AP exam and would leave off of this AP exam. I could make the argument that it fits under Taylor polynomials, which is what we have done. Where we run into some potential question marks is it also kind of fits under power series, which is a little bit past where we got to. So we're going to talk through it because I think you could approach it and deal with it, but definitely not easy at this point for us. So first thing I'm going to look at is I've got that sign of t to the sixth in there, and I noticed these series before. So I'm going to lean on sine of x, which is a series we know. All right, sine's the odd function, so I've got x minus x cubed over 3 factorial plus x to the fifth over 5 factorial, and so on. All right, that means that if I go to sine of t to the sixth, that's going to equal t to the sixth minus t to the 6 times 3, or 18, over 3 factorial, plus t to the 6, so t to the 6 times 5, which is 30, over 5 factorial, and so on. Now, this asks us for the integral of this function from 0 to x. So I'm going to take the integral of both sides. So the first term is going to go to 1/7 t to the 7th. The next term is going to go to t to the 19th over 19 times 3 factorial. And the next term is going to go to t to the 31st over 31 times 5 factorial. And this would keep going. All right, so at this point, I've got my integral in terms of t, so I'm going to plug in the 0 and x. The 0 makes every term disappear because every term had a t, so we're just really going to end up replacing the t's with x's. So not a huge structural change, just a little notation change. And then we're going to go look for this choice in the answer choices. So if I go back up, it looks like we have that exact structure right here in D. Right? And I'm going to double check just to make sure there's no other ones that match that. This one, the bottom pieces are incorrect, so we know that's off. This one, the exponents are off. This one, the exponents are off. All right, so even with the double check, D is confirmed, and that is our correct answer for this problem. Hope that helps. That's the last of these I'm going to go through from this problem set. If you have any extra questions, bring them to our Q&A session on Wednesday. Thank you.